Okay, so this is a Stirling motor. This is a basic, very simple, basic motor where you have two chambers where the air heats up in here, pushes this in, then the air passes through here, and then this sucks it. These are 90 degrees out of phase, therefore the actual flow is, the mechanics of how he built it allows the flow to create the perpetual motion, or it's not perpetual, it's just basically it's a influenced motion. In other words, the air pushes this cylinder that's inside here back. Then as the air passes through here, then it cools from these heat sinks, and even cools more with these heat sinks. So this side's creating a suction, this side is creating a pressure, positive pressure, which pushes. Then even as it passes, it creates a suction, which allows it to go, basically push, pull, push, pull, push, pull, push, pull. And the actual motion of it going sort of influences each other. This one influences that one, and that one influences that one. But it's all started by this heat that's created here, which is just a small flame. The interesting thing about the Stirling motor to me is the simplicity of it. There's really not that many parts to this. When you really look at what it does, you could probably even build it with fewer parts. This is sort of a more fancy model. It could be engineered even, it could be balanced and get even better response out of this motor. So it is very simple. It's something that they used really a lot back in the old days with the wood burning motors and all that. But, it's sort of like more about going back to old technologies that this is nothing new. This is just a little more fancy.
Good old Wikipedia for us. Here we go. A little explanation of how the Stirling engine works. So we have up here at the top a heat source. And this heat source is going to heat up the air inside of this compression area right here, inside this chamber. As that air heats up, it expands, the pressure increases. So as it heats up, boom, pushes the piston back. As that happens, it also pushes some air over into here, which causes this side of the piston also to move up. And when this side of the piston over here moves up, it actually cools off the air. So there's kind of the cold reservoir over here, and that's why you see all those little kind of, I guess I don't know whether they're called cuts or flanges, what the specific term is, but that's part of the cold reservoir. And so that hot air is also moved, some of the warm air is moved into here. It cools off. As it cools off, it compresses down and then compresses it back in. So you kind of get this rotating cycle keep moving through. They're different. This is kind of just one way you can see different kind of animations of how it works with the expansion due to heating and then compression due to cooling of the different gases. And that's how you got to get that motion.
And then you can even burn other types of alcohol as long as you know what you're doing and what it is. So basically what's happening now is there's the air that's between those two cylinders here is heating up. So if you give it a little push, you'll notice that it spins a lot longer than it did. Well, it's already taken off. Usually takes a few seconds longer than that. But basically now you have air that's heating, being pushed into here, pushed through here, and sucked out here. And because these are 90 degrees out of phase, it creates sort of influenced rotation, an influenced continuum.
So here's just a simple machine here where we have, this is actually a Stirling engine, and we have some heat source on one side here. That's the flame. It's powered by denatured alcohol, and due to it sucks in some of that thermal energy, and it spits it out, and it creates some work off of that. So that's really just kind of the simplest way for this machine to run. This is one of a very simple style Carnot engine, I guess you could say. And what I'd like you to do tonight for your homework is to come up with 2 different ways to determine the efficiency for this engine here. So there's a couple things that you can think about thinking with efficiency based on temperature, heat, and work done. So come up with two different ways to determine the efficiency of this engine.